So we currently, all of 5.3 is taking the trigonometry that we were able to use with an acute angle and putting it on any angle around a coordinate plane. This I just left on here because I wanted you to have these definitions, y over r, x over r, y over x, all these, okay? What we are going to talk about is the signs of the trigonometric functions, which is kind of confusing because by signs, I mean whether they're positive or negative. I don't mean sine as in S-I-N-E, as in the trigonometric function called sine. I'm talking about whether they're positive or negative. So down here on your coordinate plane, you zoom out a little bit. I just like made this so we could put all of our information on it.
So how many colors are we using today?
I'm not color coding things.
You're not today?
No, there's not. Okay, so this is my x-axis, yeah?
Yeah.
So over here, x is positive. Over here, x is negative. Yeah, we all good with that?
No.
Why?
Yes. Up here, y is positive, and down here, y is negative. Okay. Oh, I'm off the page. Okay.
Or is it?
Okay. So we've got a coordinate plane. X and y can be positive or negative. We have three trig functions, sine, cosine, and tangent. Then we have their reciprocals. We're just going to talk about the three trig functions, and then the reciprocals will have the same sign as them. So sine and, also r is always positive because it's your radius. So from 0 out will always be positive. So if you want to put a little note down here that says r is always positive. So in quadrant 1, sine is y over r, so that's going to be positive over positive. Cosine is x over r, so it's going to be positive over positive. And tangent is y over x, so it's going to be positive over positive. So in quadrant 1, all of your trig functions are positive. So in quadrant 1, all 6 of your trig functions are positive because your x, your y, and your r are always positive. Okay. In quadrant 2, our sine function is going to be y over r. So sine is going to be positive, and then also cosecant is positive. So I'm going to write down sine and cosecant, positive. I spelled cosecant wrong, so let me fix that. I started into cosine when I meant cosecant. Okay, so sine and cosecant are positive. Everybody else ends up being negative because x over r, which would be cosine would be x over r, that would be negative, and then tangent would be y over x, that would be positive over negative, and that would be negative. So in quadrant 2, sine and cosecant are positive. I'm not going to write down that the other ones are negative. It's just that these ones are positive, the rest are negative. In quadrant 3, we've got y over r for sine, so sine is going to be negative, x over r for cosine, so cosine is going to be negative. The only trig function that's positive in quadrant 3 is tangent because negative y over negative x, negative divided by negative is a positive. And so therefore tangent and cotangent are positive. Because it's always a function and its reciprocal. And then the last one, quadrant 4. Wow, Mrs. Ho, you're really good at Roman numerals.
Wow, Mrs. Ho, you're really good at Roman numerals.
I remember to not just do 4 tally marks. And I remember to do Roman numerals in the first place.
I don't know Roman numerals.
We'll learn those later. In quadrant 4, Sine would be y over r, so that's going to be negative. Cosine would be x over r, so that one is positive. So cosine is positive, and its reciprocal secant are positive. Then tangent is y over x, so it is also negative. Okay? So in quadrant 1, all of your functions are positive. In quadrant 2, 3, and 4, only one pair of them is positive. So it's sine, tangent, and cosine. Here is your acronym to remember it. All star trig class. Yay! Okay? All sine is S, tangents T. Yeah? That's us. A real all-star trig class, let me tell you.
Oh, I read it as star all trig class.
Oh no, it goes in the order of the quadrants. Yeah, so you have to go around in the order of the quadrants. 1, 2, 3, 4. All-star trig class. So that is how you remember that it's all of them, sine of them, to all of them, sine, tangent, and cosine. Yesterday we were talking about this backstage because I was explaining this to Brenda because she knew she was going to be gone today for a bowling tournament, and I was asking because the acronym I learned was all students take calculus. I'm not using that acronym because I know a bunch of you guys aren't taking calculus. Also, then I asked Miss Swati what she uses, and she said add sugar to coffee. To which Miss Wishman then responded, was like, no, add creamer to coffee. And I was like, Wishman, it's an acronym. You can't just change the letters because you want to. Okay, so that's all. Flip this over. We've got 2 examples on the back. Your assignment has 6 problems on it. The first 3 problems are like the first example, where it says, figure out which quadrant the angle is in. So we are told that tangent is negative and cosine is positive, because tangent is less than 0 and cosine is greater than 0. So I'm going to real quick right here, just write A, S, T, C. That's going to help me out. I know it's not quadrant 1 because they would have to all be positive to be in quadrant 1. Tangent is negative, but cosine is positive. The only place that cosine is positive, that not everybody's positive, is quadrant 4. So my answer to this question is literally quadrant 4. That's all you're doing for the first 3, is identifying which quadrant of the world we are in. Yeah, so tangent's negative, cosine's positive. So then you say, okay, it has to be quadrant 4, because that's the place where cosine is positive, but tangent is negative. Okay. Then the other thing that we are going to do is we are going to have you evaluate the other trig functions based on giving you one trig function, and then some of them tell you what quadrant it's in, some of them tell you another fact. So for this one, we are told that tangent is negative 2/3. So we know that tangent is negative. And we're told that cosine is positive, it's greater than 0. So we know that cosine is positive. This is the exact same as the example we just did. Tangent negative, cosine positive. So we can say, I know that this is in quadrant 4. So your first task is to figure out what quadrant it's in. This is in quadrant 4. That's literally the exact same as the previous example. Any questions about that fact?
All right, what about the second part of that?
Now finding the remaining trigonometric functions?
Yes.
Okay, so now we know that tangent is negative 2/3. And we know that tangent is y over x.
Bro, we have to do real math.
Mm-hmm. This is a real live math class. Okay, so this, what we're about to talk about, is probably the trickiest little teeny tiny piece, and that is figuring out whether it's the y or the x that is positive and whether it's the y or the x that's negative. Because negative 2 over 3 could mean negative 2 over positive 3, but it could also mean positive 2 over negative 3. So that's why we have to know we're in quadrant 4. So if we think about being in quadrant 4, we're down here. My y is negative, my x is positive. Because I go over and down. So my y is negative, my x is positive. So we're now able to use y is negative 2, x is positive 3, and we need to solve for r. So r is the square root of x squared plus y squared. So that'll be 3 squared plus negative 2 squared. So that'll be square root of 9 plus 4, which is square root of 13. I'm going to pause right now to mention the one thing that always trips people up is if you have tangent in quadrant 4, if the fraction that you are given is your tangent in quadrant 4, tangent is y over x. So the tangent you're given will be positive because the negative divided by a negative divided out. You need to make your y and your x both negative if you are in tangent in quadrant 3. If you're in quadrant 3, your x and your y will both be negative. Get me if you get stuck on that. Okay, so then now from here, we are just going to do our trig functions. So sine is y over r. So that's negative 2 over square root of 13. Scoot all this down. Rationalize that denominator. Multiply by rad 13 over rad 13. The square root of 13 moves to the top, and then the bottom is just regular 13.
Do we have to actually rationalize?
I can log into Math Excel and check. I didn't look on this one. Because you did it on the last one, did you?
You didn't have to, but I still did.
Okay, yeah. Okay, then cosine is yeah, 3 over square root of 13. That's x over r. Radicalize that denominator. 3 rad 13 over 13. Tangent, you won't have to do because we already know tangent. It is going to ask you for cotangent. So cotangent would just be the flip of tangent. So instead of negative 2/3, it would be negative 3/2. Already done tangent. Secant would just be the flip of cosine. Flip it before you rationalized it, so it'd be square root of 13 over 3. And then same with sine. Flip it before you rationalize it for cosecant. Square root of 13 over 2. I'm going to put the negative out in front. It's kind of hard to see. I should have done a better job of that. Please let me do a better job. I beg of you. Okay, so figure out what quadrant it's in. Figure out whether your x's and y's and r's, whatever you're given based on the trig function you're given, whether those are positive or negative. Solve for your third value, and then solve for the rest of your trig functions. I'm going to log in right now and check two things, whether you need to rationalize your denominators and whether or not you guys have any that they give you tangent in quadrant 3.